In the figure, 7 charged particles are fixed in the place to form a square with the edge length of 5 centimeter. So here you have, better I will copy this picture one more time. I'm going to paste one more time. So you have 7 charged particle. Better I will draw the diagram by myself. So you have 7 charged particle. 1, 2, 3, 4. So exactly form like a square. Okay. So here, if you see the picture, if you see the figure, you have 7 charged particle, and if you see this picture clearly, you have some charges in the corner and you have some charges in the middle. Am I right? So what are the corner charges here? Minus E, minus 3E, plus E, and plus 3 are the corner charges. Minus 2E, plus 2E, and plus 3E is the middle charges. So what is exactly given in this question? Actually, here you have 7 charge particle exactly form a square-like structure, and each edge length of the square is 5 centimeter. How much work must we do to bring a charge plus 6e initially at rest from infinite distance to the center of the square? So this is our center of the square. Am I right? And at a distance of infinite, you have another charge plus 6e. Now you have to take this charge and you have to bring this charge to the middle of the square. Already you have 7 charges here, and you have one more charge plus 6e, which is at rest at infinite distance. You are going to take these 6e charges from infinite distance to the center of the square. For that, how much work is needed? Why? Because already we have 7 charges here. So if you want to bring that charges from infinite, 6e charges from the infinite to the center of the sphere, you must do some work. So that value we are going to find here. So for calculating this work, I am going to split this diagram into 2 parts. First of all, I am going to calculate the potential for corner charges. Potential for corner charges. What are the corner charges we have? Minus E, minus 3E, plus 3E, and plus E. So these are all the corner charges. And for this, I'm going to find what is the potential for this corner charge. And after that, I'm going to find what is the potential for the middle charges. I'm going to find the potential for the middle charge. So what are the middle charge we have? So better I will draw the diagram again. So we have a charge exactly formed like a square. And what are the middle charges we have here? We have the middle charges as minus 2e here, minus 2e. This one is plus 2e, and this one is plus 3e. Clear? And then the edge length of the square is 5 centimeters. So better I am going to take a is the edge length. So what is the value of a? Because in square all sides are equal. So here a value is exactly 5 centimeter. Likewise, this side is also a. This side is also a. And this side is also a. Clear? Understand? Okay, now I'm going to find what is the potential for the corner charge. After I found the value for this corner charge potential, I'm going to come for middle charge. Once I found the answer for the middle charge, I'm going to find the net potential by adding the corner charge and the middle charge. And after that, I'm going to use the work done formula. Clear? So let's start with the corner charge. So what's the formula? As we already know, the potential formula is K Q over R. So let's take this is my first charge. this is my second charge, this is my third charge, this is my fourth charge. So we are going to apply this formula for each and every charges. By that, we are going to frame the equation. So corner charge potential, which is equal to KQ over R. Better, I'm going to substitute the value of the charge. What is the first charge? Minus E over R plus second charge K Q here is minus 3E over R, and the third charge plus K plus E charge over R plus K third charge is plus 3E over R. Now if you see these values, the K over R is a constant term, common term, not constant, common term. I'm going to take it outside. So K over R, which is multiplied by minus E minus 3E plus E plus 3E. What will happen? Minus E get cancelled with plus E, minus 3E get cancelled with plus 3E. But what is the potential for the corner charge? Anything multiplied by 0 is 0. Clear? Likewise, I'm going to find what is the potential for this. Potential for the middle charges, which is equal to K. So let's we take this is my fifth charge, this is my sixth charge, this is my seventh charge. Clear? K minus 2E over R plus K over R multiplied by 2E plus K over R multiplied by 3E. Again, I'm going to take the common term outside. K over R inside the bracket minus 2E plus 2E plus 3E. So what will happen? Minus 2E get cancelled with plus 2E. I'm going to write the remaining term K over R multiplied by 3E. So this is the value for middle charge. I'm not going to substitute the value right now because in the final steps I'm going to substitute. That will be easy for us. Clear? So we got the value of middle charges as K over R multiplied by 3E, and for corner charge it is 0. So I'm going to find what is the net potential. What is the net potential? Net potential, which is equal to corner charge plus middle charge potential. The corner charge potential is 0 and the middle charge potential is K multiplied by 3E over R. So the net potential here is K multiplied by 3E over R. Understand? Now we found the potential for these 7 charges. Now we have to find what is the work done for bringing this 6 heat charge from infinite distance to the middle. So we have to use the formula for work done. What is the formula for work done? The formula for work done, which is equal to Q multiplied by the net potential. So what is our charge here? We are going to bring this 6 each from the infinite. So in place of this charge, I am going to use this value. And in place of V net, I am going to use this value. So therefore, plus 6E multiplied by K multiplied by 3E over R. What is this R? R for middle charge. What is the R value, my dear? Half of. What is the middle charge R here for this charge, fifth charge? For the fifth charge, the R, because this is our center. So we are going to find what is this value. What is this value? This is half of A. So the A value is 5 centimeter. What is the half of A? So this is R, and this one is R. So for all the value for the R value for the middle charges is exactly half of 5 centimeter. So we have to substitute the value here R as 5 centimeter. So here 6 multiplied by 3 is 18. E square multiplied by K over R. Now I am going to substitute the value. 18 multiplied by 1.6 multiplied by 10 to the power of minus 19 square multiplied by the Coulomb constant 8.99 multiplied by 10 to the power of 9 divided by half of 5, which is 2.5 centimeter. Am I right? So here I have to convert this value in terms of meter, which is nothing but 0.025. So 0.025. So now I'm going to find the final answer. Therefore, work done, which is equal to 18 multiplied by 1.6 10 to the power of minus 19 square multiplied by 8.99 10 to the power of 9 divided by 0.025. The answer is 1.66 multiplied by 10 to the power of minus 25. So 1.66 multiplied by 10 to the power of minus 25, and the unit for work is joule. Clear? And you should understand one more thing. Actually, here this R is only for the middle charge. Am I right? Am I right or not? You have to see here. This is for the middle charge. But here for corner charge, what is our answer? When you multiply this value with 0, you will get 0. But what is the value of R for the corner charge? The value for R for the corner charge is different. So whenever you get the corner charge, the value of the R is different. So how to find the value of the corner charge? If you want to find the value of the corner charge, you have to just take one triangle from here. Let's we take this is A, B, C. And as we already mentioned, the all edge length is A. Am I right? So here this is A and all sides are A. So if you take this triangle ABC, we have to apply Pythagoras theorem. Therefore, AB square, which is equal to AC square plus BC square. So we are going to find the value of AB square. Why we find the AB square, brother? You have to see here, half of this diagonal is your R. So once you find the diagonal, divide by 2, you will get the value of the R for the corner charge. But when you come for the middle charge R value is very easy, which is nothing but the half of the value of A. But here it is different. So if you have any values, if you got any value for the corner charge, then you have to go for this method. So what is the method? Just consider half of the triangle. That means the right angle triangle, because in the square you have two right angle triangle. So I'll take one triangle ABC. Then I have to apply the Pythagoras theorem. Now what will happen? What is the value of AC? Which is A. A square plus BC, again another A. So A square. So the value of AB is nothing but is a diagonal. Am I right? Therefore, AB square, which is equal to 2A square. Therefore, AB, which is equal to A root 2. Am I right? And this AB is the diagonal. And then if you divide this diagonal by 2, you will get the R value. So diagonal divide by 2 gives the value of R. So A over root 2 over 2, which is equal to A over root 2. Clear? This is the value of R for the corner charge. And what's the value of A? Here A value is 5 centimeter. So you should remember these things. It's very, very important, because this question is really a very lengthiest question. For corner charge, R value is this. But for middle charge, it's a half of A. Your R value for middle charge is half of A. Clear? But luckily, our corner charge gets 0. So anything multiplied by 0 is 0. So here K value is 8.99 multiplied by 10 to the power of 9. And R value A over root 2. So if you divide this 2 with root 2, you will get A over root 2. And in place of A, you have to substitute. So you will get some value for R and K. But you multiply this value with 0. That's what our corner potential becomes 0. Understand? Okay, this is the method how to solve this question. In exam, we will give one of the part. Clear? Because this question is quite lengthy. So you have to read the questions very carefully before you answer.